Hey guys, today we're taking a look at slope. So we've got a little notes today. It's not really a particular section in the textbook. It's somewhere between 3.3 and 3.4. I'm just talking about intro to slope here. So we've spent a couple of days now, or I guess just Monday, on slope in general. Looked at steepness of lines. We talked about equivalent ratios of finding when two things have the same steepness or have the same angle to them. But the formal definition here that we'll use, what is slope? It is the rate of change of a line or a linear function. So it's a rate of change. It's how quickly your y values move compared to your x values, which we'll get to in just a second. But it's a rate of change. It's just looking at how quickly my line is changing by. We got four different classifications, four different types of slope here. Our main two, these first two right here, we don't usually have to label them as their positive and their negative slopes. It's just going to be, as we go through and calculate what the slope is for that particular line, we'll just end up with a number that is either positive or negative. But the way that we would describe these, when they are positive and when they are negative, just like you read a sentence and just like you read a word from left to right, we do the same thing here for our lines. So as you go from left to right on my line, if the y values are going up, meaning the right side of my graph points up, that is a positive slope. As you move from left to right, if your graph goes down, the right side goes down, that is a negative slope. Our other two special cases, which again, you looked at a little bit with the which is steepest Desmos activity on Monday, where you looked at the last couple of questions were on these two special lines, our horizontal and our vertical lines. Here, if we're looking at the steepness or the way that my lines are sloped, the easier one I think is the horizontal line. For that one, that's which is the one on the right side here. My horizontal line doesn't have any steepness. It is just flat. So it has a slope of 0. Now, the left one here, the vertical line, is a little harder to describe what it is because it doesn't really have a slope. It's a vertical line. You couldn't stand on it, so doesn't have a defined slope. So that we just kind of, it's kind of a cheat, I guess, or kind of a cheap way of going around it. But we just say that the slope is undefined. We cannot define it because, as we'll look at in just a second, the way that we describe our slope, since we're looking at how fast our y values change versus our x values, in a vertical line, we have our y values changing as much as they want to, right? It's just a vertical line, so my y values change to infinity or negative infinity, but my x values don't change at all. So I don't really have a way to compare them, so that's why we just say it's undefined. We can't really have a slope of infinity. We just say it's undefined, which it'll make a little more sense when we look at the formula for it. Speaking of which, nice transition here, finding the slope of a line. You guys probably remember it from 8th grade as rise over run. It's how far my graph changes vertically versus how much my graph changes horizontally. Which if you remember back from domain and range, domain was my x values. That's how far left and right my graph moved or could go, the possibilities we have. And then our range was our y values, how far up and down. So if rise over run is how I find that slope, we're looking at our change in y values over our change in x values. Which this symbol right here, I'm going to annotate in green here. This symbol right there, that triangle, is the Greek letter delta. Delta. And it really means, it's a shortcut that we use in math and in science, and it means literally the change in. So delta y would be the change in x, delta y is the change in y, delta x is the change in x. And you'll see that not so much in this course. We really only use it in this section. But for those in physical science, you guys will see it. You might have seen it already with linear motion, with like finding your velocity. Velocity is your change in position over your change in time. So you might have seen that already with Mr. Chang. But otherwise, you also will see it with the gas laws and eventually in physical science. Chemistry uses it for the gas laws, some of the physical properties. We use it in physics a lot. We'll use it eventually in other classes as well. You guys will do that next year in geometry. So it's a symbol it's good to know. But again, we're going through and finding the change in y and the change in x. These next parts here, I mean, you can pause it right now and write this down if you want to. Really, the way that I find my slope from 2 points on my graph are just basically slope triangles. I'm taking 2 points on my line, and I'm looking at how I have to go vertically and horizontally to get from one to the other. Now here, this is putting it a little more formally where it forces you to start at the left point and move to the right point, just because, again, we always read from left to right, so we can go from left to right, and then it's a little more simple to do that, and you can if you want to, because then if you're always moving from left to right, if you had to move up, your slope we know is positive. If you had to move down, your slope is negative. But in general, the way that we'll do this, we'll take 2 points, and I guess kind of a little bit before we do that, we need to remind ourselves, since we're going to be describing how our graph changes vertically and horizontally, we have to remind ourselves that if you move either up and or to the right, those are positive changes. So if I moved, from left to right, if I move towards the right on my x values, that's increasing the x values. So that's going to be a positive change in my x's. Same thing moving up. If I move either down or to the left, we are decreasing x or y values, which means that change is going to be a negative change, which will become important when we start looking at what I call slope triangles. So for number one, or really for any of them, you're always going to start with finding 2 points. It does not matter which 2 points you use on the line, as long as they are points and they are on the line, then you're allowed to use them. I always suggest using what I call grid marker points or coordinate points, because I want to choose ones that are on a nice intersection of those grid lines. So here I've got 3 different options you could choose from for nice grid marker points or grid line points, but you only need to use 2 of them. So if we use the 2 that I've already got kind of put in there with the dots on the page that are printed there, those 2 points, if I'm going to use those, I now have to look at how can I get from one point to the other by only doing vertical or horizontal movements. I can't move along the angle that my line goes. I have to just go either up and down or left and right. So it doesn't matter which one you start with. If I start here and I go, I'm going to say I'm moving down and then to the right. So I'm going from one point to the other. I now have to describe what kind of change that was. So moving down, again, I'm moving down 1, so that's going to be a -1 for my change in my y value, my rise of -1. And I move to the right 3, which is going to be a +3 because I'm moving to the right. I'm gaining x values, but I'm losing y values, going in this direction. So this then becomes, this is my rise, this is my run, because that's how far, rise is always how far up and down you moved, run is how far left and right you moved. So if I put those 2 things together in my slope, which my slope is always rise over run, -1/3. Once you have that in the fraction form, you just need to make sure that you reduce that fraction if and when it's possible. So in this case, -1/3 does not reduce at all, so -1/3 is my slope. Okay, we'll try a couple more. For this next one, okay, I've got 2 points, 3 points that I could choose from if you want to. Doesn't matter which 2 you use. Let's use 2 that are spaced out a little bit further. So if I want to do that, and also, again, it does not matter which direction you go, whether you move from left to right, top to bottom, it really does not matter. If those 2 blue points that I have colored in there are the ones that I'm going to choose, and let's just say I want to start here. I want to go from here to there. So now I'm moving the other direction here. I'm starting in that top right blue point and moving to the bottom left one. So if I'm going to describe how I did that, I went down 1, 2, 3, 4, 5, 6, 7, 8 units. So down 8 would be a negative 8. And then I went to the left 2, which is a negative 2. Once I have those two values, my slope is rise over run. So negative 8 over negative 2. Now with this one, we do have something to reduce. Both top and bottom are negative, so a negative divided by a negative is positive, but also 8 divided by 2 does reduce as well. In this case, it comes out to a nice single number, a nice clean whole number of positive 4. Last one here, number 3. Again, I'm just going to do this one a little bit quicker. So I've got 2 points there. I'm going to use those 2. I go down 2, and to the right, 1, 2, 3, 4, 5, 6. So down 2 is negative 2, over 6 is positive 6. So negative 2 over 6, that reduces to a negative 1/3 would be my slope. Okay. Notice here, and this is something that we'll get to later on down the road when we start talking about parallel and perpendicular lines later this chapter. If you guys notice, number 1 and number 3 had the exact same slope, negative 1/3. And the graph, they have the exact same steepness. They're just in different positions, and that should be the case. If I have two lines that have the same slope, they should be the same steepness. The angle that they create should be the same. All right. Another type, or I guess another style of question, another set of information that they can give you to start the problem would be to give you a set of coordinate points. So my coordinates here, my 2 options on how I could find that. With this first one, you could just plot the 2 points and then do the same thing we were just doing. So I'm not going to take a whole lot of time to do that. But if I put something in here, like here we got A and B, so 2, 3. B was negative 2, 3. If I take those 2 points and find the slope between the 2 of them, I'm just going to do slope triangles from there. Here it's a special case because I don't have any rise, I just have run. So my rise would be 0, my run would be negative 4, or positive 4, it doesn't really matter which direction you go. So I have a slope of 0. But that's option number 1. Plot the points and then do the exact same thing as what we just did on the previous 3 problems. The newer one, the new way that we can do this as well, is using the slope formula. So here, this is still just looking at my change in y and my change in x. It's just that we're using x1, y1, and x2, y2 for that formula. So when we go through and do this, we're going to do a little subtraction to find my change in my y values, and then my subtraction to do my change in my x values. So when I am doing this, it doesn't matter which one you label as point 1 and point 2, and which order you go in for the subtraction, as long as you keep it consistent. So if I wanted to label for this first one we've got here on the page, if I wanted A to be 0.1, that would mean x1 is negative 7, y1 is positive 1, x2 is positive 4, y2 is 0. So knowing what those are, I just plug them into my formula. My y2 minus y1 would be 0 minus 1. x2 minus x1 would be 4 minus negative 7. And I just do that math. Negative 1 over positive 11, because when we subtract a negative, it's like adding. So my slope is negative 1 over 11. Again, it does not matter which one you label as either one of them, because my fraction will reduce. It's still going to come out to be the exact same thing. So here, if I do negative 13 minus 9, that's my y value subtracted. Since I started with negative 13 up top, I have to start with 11 in the bottom. So that's why in this case it has to be set up that way based on my choice. So negative 13 minus 9 is a negative 22. When I subtract negative 3, I get 14 in my denominator. And then I just have to reduce that fraction. They're both even. So negative 11 over 7 is my slope. That's all I got for you guys today. There's obviously more problems here on the worksheet, but that at least gets you a couple of problems of each different type. The homework is the worksheet that I just posted on Google Classroom. You guys just have to do 1 through 16 for that, because those are the ones that the first 8 are from the graph, the second 8 are from a set of coordinates. The last ones, 17 through 20, whatever it is, 24, you don't... you don't have to worry about those ones. If you got any questions, as always, feel free to reach out and let me know. If you have any questions, concerns, thoughts, hopes, dreams, ideas, any of that stuff. If not, I'll see you guys soon and have a good day.